Okay, yan. Tara. Aral na tayo. Monday na naman. Okay, good morning class. Tutuloy lang natin yung lesson from last time. Last time, di ba, nag-introduction na tayo about the magnetic fields and how to imagine them. So, ngayon, ano ba yun yung ano, di ba? Tama yun. Okay, right-hand rule produces the magnetic field from the currents. Okay? So, ngayon, tingnan natin kung ano yung implications nun when we look at magnetic forces. Okay, so kunwari let's imagine things. Kunwari meron kang isang charge, positive charge, and then it moves along somewhere here. Okay? So yan, pag ganyan yung motion ng charge mo. Then suddenly, may bumukas na magnetic field pointing towards the page. Okay. So it's everywhere. Okay? Drawing tayo ng ganito. Kunwari everywhere siya. Ayan. Everywhere yung bumukas bigla ng magnetic field. Everywhere pointing towards the page. So what happens to the motion of the charge? Okay? Going back, alam natin na yung F is equal to Q V vector yan, syempre, cross B, QV cross B. So, V cross B, magra-right hand rule ka para maalaman mo yung direction, di ba? So, V natin, yung motion natin, yung speed mo, velocity is going to the right. And then, your B is pointing towards the page, into the page. Okay, so by the right hand rule, alam natin that this charge is going to feel an upward force. Tama ba? Try nyo right hand rule. Okay, so ito yung makukuha nyo. Okay. So, sige, after some time na na-feel nyo na yung force, ang motion niya na pa ganito. Okay, pa ganyan na. And then again, may mararamdaman siyang force na paganto naman. Okay? And ano mapapansin nyo? Pag tinuloy-tuloy mo yan, mangyayari doon sa charge mo, iikot siya. Okay, iikot siya. Okay, so ganun yung nangyayari dun sa charge mo. So paano malalaman yung equations of motions here? Mapansin mo that for this example, makukuha mo that the radius of that orbit, di ba mag-orbit siya? Ang radius ng orbit na yun would be given by mv over qb. Okay? So for this case, iyaano mo yung q. Tawag dito. Kukunin mo lang yung magnitude ng charge. Okay. Pati ng field. Kasi kailangan positive tong bagay na to. Di ba? Positive yung radius. Walang negative na radius. Okay? Okay. So, ganun siya. And then, if you're interested about the angular velocity, you can just get this relation. Galing yan sa original na relation mo for angular velocity, which is this one, the usual form. Okay? So from here, plug in mo lang kung ano yung value ni R. Makuha mo na siya na ganito. Okay? Okay. Okay, paano nakuha yun? Sa centripetal motion mo, di ba, ang force mo is mv squared over r. So therefore, this is also equal to qvb, assuming na v cross b is always perpendicular in such as in this case. Okay, laging perpendicular dito si magnetic field at si velocity mo. So here you just solve for r, and that is r equal to mv squared over qvb, and that's mv over qb. Okay? Yan lang. Okay. So with that in mind, na yung usual nating mga charges, they would just rotate around the magnetic field. Okay, ano pa yung mga ibang implication ng ano natin? Ibang application ng magnetic force natin. Okay? So ito, meron sa libro nyo, magnetic bottle yung tawag dito. Ayan. So meron kang magnetic field coming from the coils, current coils. Like that. So non-uniform magnetic field dito. So makita nyo naman na non-uniform siya kasi lumalaki dito. Tumataba dito sa ano. Tumataba dito sa gitna. Okay, so itong kung mapapansin nyo, ayan. At this point, umiikot yun, di ba? Umiikot yung charge mo. At this point, mapapansin nyo, the force is inward. So, laging nasa loob yung ano. Laging nasa loob yung charge. So, ito yung isa sa mga paraan how you would contain ionized gases. Okay. Ayan. And then, meron ka ring helical motion. Helical naman na to, pero weird siya na helical. So, kapag yung motion ng particle mo, meron siyang y component. Okay, and then, kapag meron din siyang x component, so basically, pa ganun yung particle mo is pa ganun. Okay. Magiging helical yung motion niya. Okay, imbis na pag y lang kasi, katulad lang siya ng example natin kanina. Okay, pag ganun lang, ikot lang siya dito sa plane ng YZ. Pero pag ninudge mo siya ng onte towards the X, then you would produce this helical motion. So, anong sense ba nitong pinapaikot-ikot mo na charge? Okay? Ang tawag dito, cyclotron motion. Okay. Cyclotron motion, and then if you would papansin niyo dito sa angular velocity, if you would increase so constant si charge, no, tsaka si m sa system mo. Kuwari, naglagay ka dyan kung ano molecule, may constant na charge yun. May constant na mass yun. So what you can do is you can adjust B to your liking, and you would increase or decrease the angular velocity omega. Okay, with that in mind, pwede mong pabilisin yung yung charges na nandun sa magnetic field mo. And then what if hinarangan mo siya ng what if hinarangan mo bigla ng neutron dyan? Okay, so they would bump each other. So yung neutron, wala siyang pake, hindi naman siya tinatablan ng mga magnetic field dahil wala naman siyang charge. So kapag hinarang mo yung neutron dyan, ang mangyari, they would collide to each other and you would produce isotopes. Okay, makakapag-produce ka ng isotopes ng material mo. Okay, so kaya kung minsan nakakapunta kayo sa mga ospital, meron mga tinatawag na cyclotron na machine. So, ayun yung mga nagpo-produce ng radioactive nuclides or radioactive tracers para sa, kunyari, yung sa PET scan and so on and so forth. Okay, let's do this example. Hindi ko alam actually ano dito, yung final answer, but let's just set up the equations that we need. Okay, in a situation like this, the charged particle is a proton, positive, and the field is uniform. And the what? And the uniform. Okay, the uniform magnetic field is directed along the x-axis. Okay, similar sa picture. And then what would be our initial condition? So that t is equal to 0, the proton has velocity components v. V is okay. Meron kang Vx at plus Vz. Vzj. And then only the magnetic force acts on the proton. At t is equal to 0, find the force on the proton and its acceleration. Okay, so force on the proton, makukuha mo agad siya as Q V cross B. Okay, and then i-break down natin si Q para mas makita natin. Meron siyang Vx x hat cross plus Vz z hat cross B. Okay. And then this is just distributive. Distributive naman ng cross product. Q V x hat cross B. And then plus Q V z hat cross B. Okay, so the first term is 0 agad kasi x hat is parallel with B and cross products between parallel vectors is just 0. So this is just 0. Okay, and then you get your QVZ z hat cross B. Okay, so that's the force. Sorry. And this is just equal to MA. Okay. And then A has to be equal to QVZ Z cross B. Ay, Z hat lang pala. Over M. Find the radius of the resulting helical path and the angular speed of the proton. Okay, so this is just R. Kuha natin si R. Ito lang naman yun. Just plug in what we got. Plug in what we get. Okay, R is QVZ over joke MVZ QV. Diba? MVZ QV. Okay? Okay, bakit si VZ lang yung ginamit? Si VZ lang kasi may nakaka-apekto sa circular motion ng bagay natin. Okay? Okay, so yung bago lang dito would be finding the pitch of the helix. So that would be the distance traveled along the axis per revolution. Okay, so finding that would require the angular speed of the proton. So angular speed is Vz over R. Tama ba? Double check ko lang. Tingnan natin ang sagot. Check ko lang yung sagot, guys. Ayan. So with the angular velocity, you can obtain the period, which is 2 pi times the frequency. But frequency is just 1 over omega. The angular frequency. So this is just 2 pi over. Ay, hindi. Baliktad. The period is just 1 over frequency. And then frequency is just 2 pi omega. There, baliktad na naman. Omega is equal to 2 pi f. Sorry, ginagamit ko lang stock knowledge. Okay. Omega is 2 pi f. And then, solving for that, you can get na this is 2 pi over omega. Okay. Let me check. Okay, so the time it takes for one revolution is given by the period. Okay. So, plug in mo lang si omega. Okay, plug in mo lang si omega. And then you can get the period. Tapos, meron kang velocity na x, di ba? Meron tayong velocity na x. So, how far would the distance to travel along the helix axis per revolution? So, gumagalaw yung particle mo to the x direction by the amount of Vx only. And then if one revolution takes this much amount of time, then the distance covered would be the velocity times time. So that's the pitch. Okay. Okay, so you just plug things up. Kaya nyo na yan. Okay, and then it's nice to read about these things. May marami sa mga questions sa exam, di ba? Basa-basa lang. Chika-chika lang. So, ayun. Basa pa rin kayo as usual in your own time. So, how do mass spectrometers work? So, yun yung mga bagay na importante sa buhay niyo. As a biochem major. And then, what's a velocity selector? Okay. Gamit kasi yung magnetic forces and electric forces mo, you can deflect your particles, yung mga charged particles mo to your liking. So if, let's say, at some configuration, papadaanin mo yung charge mo, okay? And then it's affected by, meron kang forces na paganito at paganyan dahil sa B at E mo. Okay? Maayos mo yung electric fields and palitan natin. Maayos mo yung electric fields and magnetic fields mo in such a way that the forces are anti-parallel with each other, FB tsaka FE. Okay? And then, kaya siya velocity selector kasi at certain velocities, mas malakas yung isang force kaysa dun sa kabila. So kapag mas malakas yung isang force sa kabila, babangga siya dun sa sa mga plates sa gilid. So ma-absorb lang siya. Okay? Tapos yung magpa-pass through lang yung may certain velocity that equals this out. And then, ayan, Thomson's E over M experiment. So, nalaman ni Thomson kung paano hanapin yung E over M, ratio ng E over M. Okay. Okay. Now, meron tayong charges na gumagalaw and we have forces, right? Okay, so may charge ka na gumagalaw, you have a force. And that implies na pag may current ka, there must be a force acting on that current. Kasi di ba yung current is just a line of charges that is moving. Okay, so you have this formula, F is equal to IL cross B. So very similar to your original formula, which is QV cross B. So yung QV, in-extend mo lang siya. In-extend mo lang to Q becoming a current. Then L would be the length, okay, of that current. All right. Okay, so kunyari meron kang wire. Yes. Yan. Yan. Okay. So meron kang wire. It extends, no? Tamad lang tayo mag-drawing. Okay? And then the current flows from left to right. And a magnetic field going into the page. Okay. So yung current mo, the wire would feel force going up. Tama ba? Kasi right-hand rule lang. Okay, may mararamdaman siyang force going upward. Ayan. Sige. Yung unang experiment dito is that it's something like this. Si Ampere yung gumawa dito. Okay, so kuwari the currents are, dalawang wire. The currents are anti-parallel. Okay. And then, alam natin by the right-hand rule that this guy, yung nasa wire sa left, is producing a magnetic field that's circulating around it. Okay? By the right-hand rule, Meron kang field na gumaganon. Okay? And if we're gonna extend that drawing to hit this part. Okay. So, isipin nyo na lang, extend sa likod yan. Yan. So, ganyan yung magnetic field ng isang wire. And continuous yan pababa. Pero pagod tayong mag-drawing. So, ito na lang sa taas. Okay. So, mapansin mo dito sa part na meron sa right na current na sa right na wire mo, merong inward, merong into the page na magnetic field. Okay, by the right hand rule, what is the force that you will get? So this is i-redraw lang natin vectors. Meron kang I going here, then blue that is into the page. Okay, by the right hand rule, the force must be going to the right. And what if we examine the other guy? If we examine this, the right current, the right wire, meron kang magnetic field na ganyan going around. Okay, so for the left current, ano directions mo? Upward, then into the page pa rin, then to the left yung force mo. So napansin ni Ampere, nung naghang siya ng dalawang wire, tapos may current. Pag binuksan niya yung current, tumatalsik yung dalawang anti-parallel wires kapag yung currents nila anti-parallel. Tumatalsik sila papalayo to each other, from each other. Okay, and then in a similar way, if we do the parallel wires, kanina kasi anti-parallel tapos nagkakaroon sila ng repulsion. Pansin natin that drawing na lang natin yung directions. Into the page ito. Into the page. Therefore, the magnetic force is to the left. Then for the left current, meron tayong pa ganito. Tapos, what is the... Okay, for the left current, for the left wire, out of the page yung magnetic field. Therefore, magnetic force by the right hand rule going to the right. Okay, so yung dot symbol is a symbol that tells us that it's out of the page towards us. Okay, and then mapapansin nyo again, pag parallel yung currents, they would attract each other. Yan, nice, di ba? Ayan, ito. Try natin to. In figure 27.30, this one. Merong ayan. Meron kang magnetic field na uniform and is pointing out of the page. Kaya puro tuldok yung mga bagay-bagay natin. And then there is this weird wire going to the left. Current. Meron kang straight segment. Then meron kang curved na path. Okay? Then what can we do? Find the total magnetic force on this conductor. Okay, pag ganito yung mga bagay-bagay, katulad lang ng dati, magnetic force is guided by superposition. So you can just add the things up here. I-add mo lang yung mga bagay-bagay. Okay, let's do this. F is I, L cross B. Okay. And then the current is constant. So then the B is also constant. Magnetic field is also constant. Now what changes is that yung path natin. Okay. And then from here, pag mga ganito yung mga path natin, pwede natin siyang i-integrate from a small segment. There. Okay. So the force is just an integral. Integral of IL cross B. Ang problema lang natin, how do we characterize L, the path? Okay? Okay. So, let me check lang yung sa libro. Okay. Okay, bakit may message? May message. Bakit hindi dapat negative integral? Tama ba to? Negative integral ng B cross DL? Sabi mo? Okay. Yan ba yung tanong mo? Sorry. Okay. So, ang gusto mo mangyari, dapat ganito. Babalik ta rin natin. Tama ba? Ayun ba yung gusto mo mangyari? DL. Ayun ba yung ganyan gusto mo mangyari? Tama ba? Ito ba yung ito ba yung okay. So, ito yung sige. Gawin natin formally. Sloppy tayo. Sloppy yung pagkakagawa ko. Okay. So, yung F natin, i-break down muna natin into a smaller path. Then, I is constant, P is constant, DL can be broken down into smaller paths. And we have this. Okay? So, hindi ko pa siya ginagawa kanina. Sloppy. Okay? And then, pwede mong baliktaran kung hindi ka sanay na nauuna yung infinitesimal element, D. So, you can put a negative sign there. I, B, cross DL. Okay, then I could also do this. Negative I, then B, D, L, sine theta. Okay, kasi ito yung usual na multiplication, di ba? Pag cross product. Okay, we just now need to find what DL is. And DL has to be okay. So si DL natin, itong L na path natin, we could this is arc length to, di ba? Arc length. So therefore, we could express this as yung formula natin for arc lengths. So we have negative I, B, R, d theta. Okay, so d theta is a small increment of that line. Tapos, mumultiplyan mo ng radius para makuha yung small arc length. Okay. And then, we have sine theta on the side. So, meron akong negative I RB sine theta d theta. Okay. So, binaliktad natin siya, no? Binaliktad natin. So, yung cross product natin would come from B going to the path. Okay. Weird. Nakakalito siya. So, from here, yung makakalculate nating force is dapat paloob. Okay, paloob yung makukuha natin kasi sabi nga natin, B cross DL yung gagawin natin. Okay? Okay. Pero pwede mong gawin mula dito. Dito kami simula. DL cross P para mas maliwanag ang buhay para sa iba. Ay, wala. Okay, and then from here, our theta goes from 0 to, what is this? Pi. Okay, 0 to pi. Therefore, I have negative I RB Okay. So, babalik ta rin pala natin dahil dun sa no? Babalik ta rin natin yung integral dahil dun sa pagpalit natin dito. Okay. Yung implication ng pagbaliktad mo, babaliktarin mo yung direction ng current mo. Okay, so mas nakakalito pag nilipat mo sa ganitong form. Okay, nakakalito siya. Okay, going back, papapalitin mo, pi to 0 dapat ito. Dahil binaliktad natin yung path. Sin theta to theta. And this is just negative IRB. So I suggest going this path, dito na lang. Okay, mas madali itong paraan dito sa una. IRB, then the integral of sin theta is integral of theta, sin theta is just cosine, negative cosine theta evaluated at pi to 0. Okay, and this is just so negative 1. Cosine 0 is 1 minus minus cosine theta. Cosine pi. Cosine pi is negative 1. So this is just negative 1. Negative 1. Buisit. Negative 1. So that's positive 1. Tapos may negative ka pa dito sa labas. So that's negative 1 again. Negative 1 minus negative 1. Negative 2. So that's 2 IRB. Okay, so that's 2 IRB for this arch. And then the last one here is simply enough. Makukuha natin ito. So for the other part, for the straight line, this is I. L cross B. But L cross B here is always normally perpendicular, walang bago. And that is a constant length. And hindi siya kumukurba. So madali lang. So wala tayong arc length na kailangang problemahin. So this is just ILB. Okay. So alam natin from this part na ito madali lang kasi upward yung force mo, di ba? Upward yung force mo, so L. Tapos yung magnetic field natin is out of the page. So magra-right hand rule ka, tataas yung force mo. So this is X hat. And then for this part, yung ginawa natin, hindi natin nilagay. But this is, anong B natin? Ang B natin is Z hat. Z hat cross theta hat. Ay, dito pala dapat siya. Dito pala dapat mas appropriate yung ano. Okay. And then Z hat cross theta hat is just intense, no? Z hat times cross theta hat. Hindi pala to straightforward. Okay, but by intuition, let's do this. Meron kang, for this side, dito sa side na to, meron kang forces that are upward and right. Okay? And then kapag nandito ka na, meron kang forces that are upward and to the left. Okay. You know what, malalaman nyo na dito kung sino magka-cancel out. Okay, so magka-cancel out yung X part. Okay, so magka-cancel yung X part. So matitira na lang is Y hat. Ay, bakit X hat to? Y hat to. Okay. Alright. Funny, no? Ang hassle nung sinolve natin, but it's just the ano nakuha natin? 2IRB. Tapos dito, ILB. So, tinitinan mo lang dito is kung gaano siya kahaba. Walang paki doon sa kurba, no? So, this length is 2R. 2R lang siya. Okay, wala lang. Pwede natin i-generalize sa mga bagay na ganito. Anyway, continuing. Sige, kapagod yung mga example natin. Pero wala namang mga ganito sa exam, di ba? Madali lang yun nasa exam. Pero, ayan, may mga tanong sa exam na kinukuha sa mga example sa libro. So, yung mga ganito, kuwari, binigay sa exam, gagamitin nyo na lang yung formula. Okay? So, paano pag meron tayong current loop? I-analyze natin ngayon yung may current loop tayo. Tingnan natin kung ano yung forces na makikita natin. Okay, so let's try this example. In this figure, upward towards the z-axis yung magnetic field B mo. And then the current is going, may direction yung current. So, it's going counterclockwise. Ay, vertical. Okay. So, sa sides mo, walang makukuhang magnetic force kasi IL cross B. So, L mo is going upward. Okay, yung current mo going upward and the magnetic field is going also upward. Therefore, they're parallel. F is 0. But on the top and bottom lengths, top and bottom sides, makikita mo that the I is going through the y-axis. So therefore, y cross z is just going to the x. Okay? And then similarly, sa baba, going to the negative y yung direction ng direction ng current mo. And then B is also upward. So IL cross B gives me negative x direction. Okay, makapansin mo that hinahatak yung taas papunta sa x, hinahatak yung baba papunta to the left. And this would rotate the whole thing. Okay? So yung force mo, 0 lang. Kasi equal yung sa top, equal yung sa to the right, equal to the left. So that's 0. However, yung torque mo is not 0. Meron kang value since your system tends to rotate. So there's a value. Let's try the other guy. The other configuration, ganito naman, nakalatag na sa XY plane yung loop mo. So basically, ito inikot lang natin ng konti para humiga siya dun sa XY loop, XY plane. Okay, and then pansin mo, si B is going upward pa rin. And then by the right-hand rule for the IL cross B, at this side, going to the I cross B. So, papunta dito sa X yung force mo. In similar manner, ganito rin, ganito, ganito. Okay, so dito, pag ganun siya. Okay. So, going that way. And this, the current here is going to this side, papuntang X. Okay, nice. Napansin mo, 0 yung force and wala nang torque dito. Kasi wala nang hatakan na nangyayari. Ay, ito nalagay. Ay, nabaliktad ko. Nabaliktad. Okay, nabaliktad ko yung slide. Ito pala dapat muna. Anyway, going back. Let's calculate ng, calculate lang natin explicitly kung ano tong bagay na to. So, the force is IL cross B. ILB na lang. ILB. So, meron akong I, meron akong B. And then, sabihin natin L is A. Okay, so IAB. And then, i-shift ko siya by some angle. So that naisip ko ano ba yung tamang paraan para sabihin to. Okay, so drawing muna tayo para tayo lost in life. So, i-angle ko na siya ngayon. No? Angle. Yan, drawing muna tayo. Okay. Hindi. Okay, kuwari ito X, ito yung Y, ito yung Z. Tapos, meron siyang angle by this amount. Pick na lang natin. Okay, so anong point ko? Nag-current ako na counterclockwise. Tapos gusto natin kunin yung ano, 'di ba, yung torque. Torque is just R cross F. 'Di ba? Ito yung itsura niya. So yung R mo would be coming from these parts. Okay. And then, ano yung direction natin ng magnetic field? Upward yung magnetic field natin. May upward ako ng magnetic field dito. Tapos may magnetic force with this kind of configuration is going to the y-axis. Okay, so ito lang muna consider natin at this part. So may force ako na pa ganun. So parallel with the y-axis. So R cross F would simply be, let's say this is B, yung side na to. So this is just B over 2 times yung F ko, which is I A B. Tama ba? Tapos, meron akong theta. So, I have to accommodate that. So, sumisign theta pa ako. Okay, bakit sin theta lang? Kasi, if I would extend my radius here, okay, so by geometry, this is also theta. So, theta lang. Walang special. Tapos, tapos tingnan ko rin dito sa baba, sa kabila. Pag ganun yung force ko, pag ganun yung radius, and then theta. Okay, sa baba naman, similarly, ganun lang din. So this is just B over 2 again for the radius. The force is still the same, IAB, then sine theta. Okay, and then sa sides, ang mangyayari sa sides ay walang ambag to dahil yung forces mo, pag ganun siya both. Okay. Pag ganun din dito. So, walang torque dito sa sides na to. So, therefore, the total torque is just this 2. So, the sum is just tau. This is I AB capital B sine theta. And AB is just the area of the thing, of the loop. Okay. And then I could write down IA as some new factor. So that I'll call it mu B sine theta. Then mu B sine theta is something like a cross product. So we call this mu cross B. Okay. And then mu is what we call the magnetic dipole moment. Magnetic dipole moment and mu cross B. So mu is just mu. Yes. Mu is just the current of the loop. Okay? So yung area yung may direction. So for these cases, ang mu natin would be pointing for this part, pointing to the left, and this part pointing upward. Okay, paano malalaman yung direction niya? Gagamitin mo yung direction ng loop. Magra-right hand rule ka. Pansin mo, yung rotation ng currents mo is going like this. Kaya yung magnetic dipole mo is going that direction. Okay? Similarly, ganito rin dito. Right hand rule mo lang. Puro right hand rule pag magnetic yung mga pinag-uusapan natin. Okay, so upward yung upward naman pag dito sa case na to. Kasi going pag ganun yung current mo. Okay, so you have that. You have this torque for a magnetic for a current loop. Okay, di ba parang ganito rin sa electric field, meron tayong electric dipole moment. Di ba? P naman, P mo sa electric dipole moment. Then, tapos medyo, ano naman, no? Medyo intuitive yung dipole sa electric field kasi yung mga molecules natin, they constitute a dipole. Easily a dipole. Okay? So, wari ganyan. Okay, automatically, this is a dipole. May imagine mo siya. But for magnetic currents, for the currents, ang dipole ay current loop. Ang current loop. In a sense na sa chem, yung mga molecules natin, they can both be considered a dipole and a joke, and an electric dipole and a magnetic dipole. Okay, magbigay tayo ng cases na mukha siyang dipole. So in dipole, usually nangyayari siya kapag bonded na yung atoms mo. Okay, bonded na yung atoms mo. Katulad ng H2O, meron ka something like Mickey Mouse, di ba? Yung isang side mas positive, isang side mas negative. Hindi ko alam kung tama yung ano ko, no? Na this side is more positive. Tama, di ba? Kasi hydrogen to, di ba? Guys, correct nyo ako, hindi ako chem. Positive hydrogen to, tapos your big guy is your oxygen. Tapos yung magbabond sa kanya would be yung negative. So, nasa loob yung negative. Yan, nakaprotrude sa sungay niya yung plus sign. Okay? So, this looks like a dipole. But if we are to examine hydrogen atoms, ano ba itsura ng hydrogen atoms? So, yung hydrogen atoms mo, single proton, single electron, and that electron rotates around your hydrogen, your proton. Okay? So, nagro-rotate siya, and so sobrang bilis niya mag-rotate, mukha siyang current loop. Okay? So this guy looks a magnetic dipole. And magnetic dipole are very useful sa magnetic resonance imaging. Okay, dahil pag binombard mo to ng magnetic field, they would tend to align with magnetic fields. Okay, so pag pinatay mo na yung magnetic field, nararamdaman ng machine yung changes sa body mo. And that registers an image. Okay. And then, meron tayong energy. Katulad lang din sa electric dipole natin. Di ba? P dot E yun. Parang ganun. Something like that. Ganun lang din dito. Alright? Ito. So, given dito yung potential energy for a magnetic dipole under a magnetic field. Okay, let's try this example. A circular coil, 0.05 meters in radius, with 30 turns of wire lies in a horizontal plane. It carries a counterclockwise, as viewed from above, na current of 5 amperes. And then the coil is in a uniform 1.2 Tesla magnetic field towards the right. Okay, find the magnitudes of the magnetic moment and the torque on the coil. Directed towards the right. Tingnan ko lang image. Okay, for a single coil, meron kang circle, di ba? And then, radius of that amount, this amount. Therefore, mu is just I, the current I have, which is 5 amperes, that times the area, which is pi, r squared. Capital R na lang ito. Okay. And that's it. You just plug in things. Makukuha mo na siya. Okay, and then if we are to let this area, this whole thing, as this, so z hat, sabihin natin, and then x, and into the page is y. Okay, and then I could say this is in z hat. Okay, dahil sa right hand rule ko, pataas dapat yung direction ng magnetic moment ko. Okay, and then the torque on the coil would be, if the field law is going to the right. Okay, before going that way, this is for a single coil, no? So there are 30 turns of wire, therefore the total, so this is 1, the total is 30 times I times pi r squared. Okay. Sorry. Nakaligtaan ko. So z hat again. And then the magnitude and the torque. So the torque is mu cross B. Therefore, what happens? So this is mu B. Tapos z hat cross x hat. Z hat cross x hat. Okay, so my torque is directed to the y hat axis. Y hat axis yung natin, torque natin. Okay, so this is, torque is mu B Y hat. Okay, just plug in things. Just plug in things. Okay, anong ibig sabihin ng Y hat direction? Y hat direction. Ng torque, ibig sabihin, ayan. Ito yung torque mo. Kuwari, this is the, okay, for this case, yun, T natin yung green, okay? So, dun daw nakatutok yung torque mo. Ibig sabihin, yung rotation mo would be going right-hand rule. Gagamitin mo yung right-hand rule. Okay. Ganun. So, itong loop mo, tataob siya. Pababa ito dito. Tapos sa taas. Pataas dito. Okay? So, the magnetic moment tends to align with the magnetic field. Okay? So, ikot siya pa ganun. Nakakalito minsan yung yung torque kasi hala, ba't papunta dun? Parang ganun yung nasa isip mo. Tulad nito, papunta sa Y, parang out of place siya in this context. Pero ayun nga, yung torque would signify the rotation on that axis kung ano makukuha mo. So Y hat yung nakuha natin. So your rotation is with respect to that axis. Therefore, paganda yung rotation. Okay. Let's try a bit of another example, if you would say so. Pero ito ay real life example lang naman ng mga bagay-bagay natin. So suppose you have a magnet. You have a magnet. North, you have a south. Okay. And then the field of this magnet looks like this. Okay. Hindi ko nabubuuin. Pero mag-loop yan towards the back. Okay? So it looks like this. And if you have another magnet, okay, let's have another magnet here. The pink pa rin, para maganda. Nandyan ka pa ba, Dino? Hello, Dino.
Yes, sir.
Pag pinaglapit mo yung magnet, ano yung nararamdaman mo? Pag pinaglapit mo itong dalawang magnet na to.
Repulsion po.
Di ba may mararamdaman kang di sila magdidikit? Okay. So, pag north to north pinagdikit mo, thank you. May mararamdaman kang repulsion. Okay. And balikan natin yung lesson natin last time. I think that's here. Okay. This is the magnet. Ito yung drawing ko kanina. Di ba? And similarly, yung field na ganyan yung itsura is also produced by these coils of current. Okay, so these coils of current can produce the same configuration of magnetic field like the magnets that we have. Okay. Now, going back, I could model this magnet as some current loop. Okay, as some current loop. Maraming current loop yan, pero isa lang muna lagay natin. Some current loop with current going counterclockwise so that the magnetic moment is towards this. Okay? Gets naman kung bakit yan ganyan yung view, di ba? Right hand rule lang. Alright, lapit lang natin si current loop dito. Yan. Okay. Tapos towards to the right. Okay. Alright. In this part, look at this part. Meron kang current going, i-side view na natin, no? I-side view natin. Pag ganyan yung itsura niya at side view. So at this part, meron kang current na into the page. Tapos yung magnetic field mo is somewhat like this. Okay, so meron siyang vertical component and horizontal component. Okay, and then if we get the IL cross B, this means that your magnetic force at this point is going to the paganon somehow, di ba? Kasi into the page yung I, well, yung direction din ng L. Therefore, kasi ko cross ko sa B. Okay. Tapos, I have that force. And in this side naman, sa baba, ano yung direction ng current ko? Out of the page. Out of the page. And then, magnetic field somewhat this part. So, my magnetic force is towards this part. Okay? Pansin nyo, if you would continue on this side, so mga side na yun, mga yun, it all points towards the same direction, yung force mo. And that would be against the loop. Okay, against the loop. Okay, against the loop. So, mararamdaman mo yung force na repulsive in this sense. Okay? Kaya mo nararamdaman yung tawag dito, yung repulsion. Kasi, para siyang current loop. Itong bagay na to, yung magnets mo. Actually, current loops sila in molecular, in a molecular sense. Okay? So, yung mga electrons dyan, may umiikot, nasa edge lahat yung mga electrons. And they are going all in the same direction. Almost all in the same direction. Okay, and then mapapansin nyo dito, si magnetic dipole moment is against the magnetic field. So, again, sabi ko nga, yung magnetic dipole moment mo, it tends to align with the fields. Okay? So, gusto niya yung magnetic dipole moment, umikot siya pa kabila. Okay. Kaya yung south mo, dumidikit siya dito sa north mo. Kasi magka-align na yung magnetic dipole moment nito, tapos yung magnetic field nito. Okay? Nice, di ba? Nice to know. Ma-explain nyo na sa mga lay people na ba't kaya may repulsion yung magnets? Okay? So, dahil meron kang current na maliliit sa loob, and they form a current loop. And current loops experience a force due to the magnetic field. Okay. So, in the, appeal lang sa mga further lessons natin. Katulad lang din nung sa electric field, no? Meron tayong tinatawag na dielectric. And if you add your electric field to your dielectric becomes polarized. So, ibig sabihin, yung mga positive charges mo napupunta lang sa isang side ng material. And then, the other charges, negative charges, pupunta lang din sa isang side. Therefore, nagiging polar yung isang bagay. Okay. Ganun din dito sa beam mo. If you put it into a material, dielectric pa rin. And then, meron tayong tinatawag na paramagnetic materials. And then, diamagnetic materials. and ferromagnetic materials. Okay. That would become magnetically polarized or tinatawag nating magnetized. Okay, magnetized yung tawag sa kanila. Okay, si paramagnetic, pag tinapatan mo siya ng magnetic field, yung magnetization niya, mag-a-align lang dun sa magnetic field. So basically, parang nagiging magnet yung bagay kapag paramagnetic siya. Diamagnetic, kabaliktaran. It opposes the tawag dito, the magnetic field that it's experiencing. So yung pinaproduce niyang magnetic field is to counter the magnetic field applied to it. Ito yung mga materials na ginagamit for magnetic levitation. Yung nakakanood kayo ng mga YouTube videos na may pinapalutang na bakal sa isang magnet. Those are diamagnetic materials. Kaya siya lumulutang kasi repulsive yung reaction niya, yung pinoproduce niya magnetic field, and that produces a repulsive force dahil kinokontra niya yan. Nagpo-produce siya ng current sa loob niya. Okay, and then lastly, ferromagnetic materials are a special case of paramagnetism. It's just that pag natanggal na yung magnetic field, yung mga ferromagnetic materials mo, they would stay the same, they would stay magnetized. Sa paramagnetic kasi, pag natanggal na yung magnetic field, they're back to normal materials again. Okay? Yung ferromagnetic, nagiging magnets sila afterwards. Okay, I guess that's it for the lesson today. Wala masyadong mahirap na well, may ganito pero again, di naman kayo nagko-compute ng ganito sa exam. Okay, sige, that's it for today. Do you have any questions? Do you have any questions? Kung wala, class dismiss na tayo. Mag-check ako attendance. Sayang naman. Para may bonus kayo. Okay, screenshot ko na lang. Okay, sige.